Hello, this is HWInfo, and today we're going to take a look at some different Intel-based mini PCs, and based on the Intel Celeron N5105, but also the new 12th gen processor N95 and the processor N100. And going to kind of compare and contrast both features of the mini PC, but also what the heck is the difference in performance between the older 11th gen Celeron N5105 and the newer processor N95 and N100. And what we have here are four of those devices. We've got two Beelink devices. This one is the Beelink S12 Mini, or the Mini S that they call it. And this has the the Intel processor N95. And this Beelink U59 has the Celeron N5105. Now these other ones that are called Trigkey, they're very kind of similar devices, and these both have Celeron N100s on them. Now one thing you'll notice though is that the N95 and N100 can accommodate both DDR4 or DDR5 RAM. So this one actually has a DDR4 RAM in it, and this one actually has DDR5 RAM in it. So let's go ahead and take a look at the specifications over on the Intel website real quick for these processors to kind of get an idea for the differences, and then we'll go from there. Alright, this is Intel's website, and I have the three processors here, the Celeron N5105, the N95, and the N100. You can see here real quick that the lithography, the Celeron is the 10 nanometer process, and the N95 and N100 are the new Intel 7 process, which I'm assuming is 7 nanometer. And going down here, you can see they're all 4-core, 4 threads. And as far as the TDP is concerned, the Celeron N5105 is a 10 watt, N95 is a 15 watt, and the N100 is a 6 watt. Now, when I do some benchmarking, I want to see how that comes into play, if at all. From what I have seen, though, it really doesn't mean a whole lot. So it's really kind of more your idle TDP as opposed to actual performance TDP. And as far as launch date, you can see that the Celeron is a couple years older than these processor N95 and N100, and they can both all accommodate 16 gigabytes of RAM. The difference is that the Celeron can accommodate dual channel DDR4, whereas the N95 and N100 can only accommodate single channel RAM. Not sure why that is, but that's what it is. And I will also confirm that with these devices, and I'll show you on the inside that these only have a single RAM slot too, so you can't really see if you can actually get dual channel to work. But in any case, N95 and N100 can accommodate either DDR4 or DDR5. And when it comes to graphics, they don't have much detail here, but you can see here the N95 has fewer execution units than the Celeron and the N100. And they can all accommodate 4K 60 Hertz, and otherwise the rest is pretty much common. Number of PCI Express lanes, 9 on the processor N95 and N100, 8 on the Celeron, and then you can see here, what else are we looking at? SATA ports. While the Celeron says it accommodates 2 SATA ports. Both the N95 and N100 versions of this mini PC do have a SATA port on it. So I'm not sure if they're using some sort of translation from PCIe to SATA or what. And I believe that's about it. All right, now we'll go ahead and take a look at the devices themselves. Okay, first up, we're going to go ahead and take a look at the Beelink U59 here, which has the Celeron N5105 CPU in it. This is the looking at the options and ports. You've got dual USB 3 of some sort, a USB-C, a headphone microphone combo jack here, power button, a reset CMOS button. You can see the ventilation there. And on the back you've got dual gigabit LAN, 2 more USB 3 ports, and then dual HDMI, and then the power jack. Bottom has a mounting bracket, mounting provisions for that. And it actually has some comments here on press delete to enter BIOS, F7 to enter boot, which is a nice thing to have, I think. And it's a plastic construction. And if we go ahead and open this up, Now one thing you'll see on these other ones, they actually have a pull tab at the bottom, but this one does not, so you have to put something in here. Now there are 4 screws. I have already removed them that hold this down, and then you just kind of pry this off. Now be careful if you open one of these up, because there is a SATA cord attached here, and you can easily pull it out. It can reattach, but you don't want to cause any undue stress. So obviously you have your 2.5-inch 7mm height SSD or hard drive slot there, probably SSD these days. You've got the M.2, in this case this one has an M.2 SATA, and it has a 500 gigabyte one in here. The other ones have M.2 NVMe, and then this has the dual channel DDR4 slots. And let me grab, if you remove the SSD, you can see here it has a removable Intel, this is Wi-Fi 5, so 802.11 AC wireless card here, and it is a M.2 Wi-Fi card, so that is replaceable as well if you'd like to. And then onto the RAM, you can see here you've got dual slots, so these accommodate DDR4 up to 16 gigabytes, so 8 gigabytes per. Now I did put a 16 gigabyte chip inside of here, and it did not register a single 16 gigabyte chip, so 8 gigabyte in a single slot is the maximum you can do. You also notice that it has the this pad is kind of stuck to here, but it's basically supposed to touch down to the SSD here to help with cooling. And otherwise, you can see the other components here. There's not much else to see. I'm going to go on the back side of these in a little bit and show you that with the cooling and everything. Okay, so now moving on to the Beelink S12, Mini S12, S12 for 12th generation, I'm assuming. Again, it's got the 4 screws, and it has this nice little pull tab here. Just pull up on that, and then again, be careful because of the SSD. Now for the SSD, they do recommend, obviously this is covering it here, I'll go ahead and move this over to here. But it does recommend that you remove these screws here, but it's just as easy to just slide it in this way. To get it out, you might have to just push something against there to get the SSD out, or else you just remove those 2 screws. So this just slides in just like that. Poof. And taking a look inside here, you can see you've got your M.2 SSD. This is the M.2 NVMe. In this case, this one is a 256 gig that came with it. This also came with an 8 gig DDR4 RAM in it, and I replaced it with a 16 gigabyte just so we could do common performance metrics here. And that is the maximum that it will accommodate. Single stick of DDR4, so single channel RAM. And you remove the SSD. And that's all you have underneath. And then this one, you can see it's got the also the Wi-Fi 5 or Intel 3165, I believe, chip. And this one's actually soldered. It's integrated as part of the motherboard, so you cannot swap that out, unfortunately. And I realized I didn't look at the ports around the outside of this guy. So what we have here is 2 USB 3. I think these are 3.2. The clear CMOS button, the headphone, microphone combo jack, power button, again, cooling vents here. You've got a dual USB 3 Type A back here, a single gigabit Ethernet LAN, 2 dual HDMI 4K 60 supports apparently, and then the DC jack here, Kensington lock, and that's about it. Now this also is all plastic. This one is a little different because it actually has some sort of texture to the surface, so it looks a little nice. Okay, now moving on to the Trigkey G4. You can see here it's got the Intel Inside logo on here. It looks like these all do. At least this one does, and this one does not. So in any case, then it's got the logo here, and again, plastic on the outside, and you've got the clear CMOS button here, dual USB 3 Type A, a headphone microphone combo jack power button, and then you've got the cooling vents here, and then in the back you've got another 2 USB 3 Type A, that's a gigabit Ethernet LAN, and dual 4K 60 HDMI ports, and then obviously your power button and your Kensington lock just like the other one, and it's got the pull tab here like the other guy. We'll go ahead and open this up. very similar to this one. You've got the M.2 NVMe here. You've got a single channel DDR4 RAM here. Again, this is 16 gigabyte. Pull this off. And the single channel slot for RAM. And then again, you've got the Wi-Fi card, which is soldered on this guy too, except this is Wi-Fi 6. It's AX101 Intel Wi-Fi 6 card there with Bluetooth 4.2, I believe. And again, the SATA slot too. And lastly, we've got this Trigkey G5. And this actually, it's all plastic, but it's got a little bit different finish to it. It's also, you notice the ventilation is actually some sort of like a metal grate here, as opposed to just the plastic pass-through there. And then here you've got the clear CMOS button. You've got the dual USB Type A there, the headphone microphone combo jack, power button, ventilation as we showed. And then you've got a USB. Now that's not blue, but I do believe that that is actually a 3.2 port, and I do have benchmarks for that. And then you also have a Type C USB port here, which accommodates both USB data as well as DisplayPort. I also wanted to mention, I should mention on the Beelink U59 that USB-C also supports DisplayPort. And this actually has dual 2.5 gigabit Ethernet jacks, so that makes this a nice little, it could be a nice little NUC for some basic file storage or router or something. Then dual HDMI ports, so you could have actually 3 monitors hooked up to this, 2 through HDMI and 1 through the DisplayPort on the USB here, and then the power jack here. At the bottom here, you see that. And then like the others, you just remove the 4 screws around the outside, pull up on this tab, and again be careful of the cable here. And you can see you've got your SATA slot there like the other two. And here you've got the DDR5, okay, a single channel, single slot DDR5 RAM stick here. And then you've got your M.2 NVMe. This one is a 500 gigabyte, 512 gigabyte, whatever. And underneath there has the Wi-Fi card, and this one again has a removable M.2 Wi-Fi card there, and this one is also Wi-Fi 6 like the other Trigkey. The Beelinks have the Wi-Fi 5, these Trigkey ones have the Wi-Fi 6 AX101 Intel. So you could actually swap that out if for whatever reason you wanted to. It's good to see. Okay, now before we go ahead and dig inside of these, let's do a quick rundown of the specs here and go over to the computer. Okay, here we've got the Beelink U59, Beelink Mini S12, Trigkey G4, and the Trigkey G5. And you can see the CPUs, the difference in those, the total RAM, again, the DDR4 dual channel on this guy, and just single channel on these other 3. And the storage, they all have a SATA slot, as you saw, for a 7mm height drive. And the Beelink U59 has the SATA M.2, whereas the rest have NVMe M.2 drive slots. They all have an active cooling fan, and we'll go ahead and take a look at those in a minute, and with heat sink and heat pipe and all that fun stuff. And they all come with Windows 11 Pro. Now looking at some of the ports and everything, you've got the HDMI. Now the Beelink U59 and the Mini S12, they claim 4K 60, but for whatever reason I can only get 50 hertz out of these guys at 4K, whereas on the Trigkey I could get the 4K 60 no problem. So I'm not sure if it's an issue on my end or if that's just what the device can handle. As far as DisplayPort, both the Beelink U59 and the Trigkey G5 both have a DisplayPort through the USB 3 Type C port. And then as far as USB is concerned, the Beelink U59 has 2 Type A. The rear ones are actually 5 gigabit and the front ones are 10 gigabit, along with the USB Type C are all 10 gigabit. And I have confirmed that, and I'll show benchmarking on that. And then the rest of them all have 10 gigabit USB 3.2 ports. As far as networking is concerned, the Beelink U59 has two 1 gigabit Ethernet ports, and the Beelink Mini S12 and the Trigkey G4 only have one gigabit Ethernet port, all RJ45. The Beelink units have Wi-Fi 6 or 802.11ac and Bluetooth 4, whereas the Wi-Fi 6 devices on the Trigkey have 802.11ax, obviously backwards compatible with AC, and they also have latest Bluetooth 5.2. And again, the Trigkey has the dual 2.5 gigabit Ethernet ports. Now, as far as headphone, they all have that single 3.5 millimeter audio out mic combo jack, and there are no micro SDs on any of these. They all have the exact same power plug, and I'll show that in a second here. Okay, as far as power delivery, these guys all have the exact same power adapter. They are 12 volt, 3 amp, and it's got the 5 mil and 2.5 mil barrel plug to it, so they're all pretty much interchangeable. And we'll go ahead and take a look at the power consumption as well with these and see if this is adequate. Now, I already recorded a video opening these up, so I'm going to go ahead and play that. So there may be some repeat stuff in there, and I apologize for that, but you can at least see the insides with the cooling solution and everything else. Yeah. Let's go here. All right, so if you take a look here, obviously your thermal solutions here are a little different. This guy looks a little bit smaller than this guy, but this is the Celeron N5105, although it does have a higher TDP. Despite that, this only runs at about 20 watts, whereas this can run at, I think I saw somewhere from 25 to 30 watts actually, despite the TDP rating. And this N95 over here has a significantly thicker heat sink than the N100s over here. So, although it looks like a pretty beefy solution, you can see the nice thermal pipes here. So next we're going to go ahead and take a look at the BIOS of each of these devices. The first up here is the Beelink U59, and we'll take a quick look at each of the devices, but they're all very similar. And as we go through here, you'll see that there's a lot of configurable options here, right? But just because it's shown in here doesn't necessarily mean it actually takes effect on the system itself. So it's like they unlocked everything in here as far as visibility, but just because you make a change to these doesn't necessarily make effect to the system. For example, under thermal configuration here, I did mess with the trip points for the fans and the fan speed, but it really didn't seem to have any effect on the actual fan speed or the trip point for that. So I'm just going to kind of plow through here real quick, and you can see otherwise you have your basic secure boot and boot priorities, etc. Okay, here is the Beelink S12 BIOS, American Megatrends. Again, a whole slew of configurable options here. Chipset, security, secure boot. Okay, here's the Trigkey G4 BIOS. Again, American Megatrends. Looks very similar to the S12. Okay, here's the Trigkey G5 BIOS. Very similar to the other two, the S12 and the G4. Alright, here we are booted into Windows on the Beelink U59, and I'm going to kind of go over the HWInfo 64 real quick for each of these devices, just to confirm the specs that we looked at. You can see here it's got the Celeron N5105, 8 gigs, 16 gigs, sorry, of DDR4 and dual channel, running at 1066, 2133 megahertz. Let's see here, well, no, it says clock 1333, so it'd be 2666. And both banks are populated. And then we've got Windows 11 Pro here. And if we go into settings here and look at the system, about, and you can see here Windows 11 Pro, and go down to activation, and it is definitely activated, so no problem there. And then a few other details we can go ahead and take a look at. There's the Celeron processor we talked about, and what else? There's a RAM, drives, a SATA drive right there, and that's the thing, there's no real, there's the drive, where's this part number for this? It's just the drive model, 512 gigabyte SSD, so some generic version. And then audio, it's got the integrated Intel audio networking. There you've got the AC 802.11ac Intel 3165, and then you've also got the dual gigabit Ethernet, and then all the ports. So there's that on the Beelink U59. Alright, here we have the Beelink Mini S12, and there's the Intel processor N95 using the Intel 7 process, 15 watt TDP, Alder Lake N, and we've got 16 gigabytes of DDR4 in single channel, and it shows 0 banks of filled, which is correct, and it's at 3200 megahertz, 1600 and 3200 there. So, and then we have Windows 11 Pro as well on this guy. And so if we go to System, down to, there it is, Windows 11 Pro, and it is activated, no problem. We go over here to some of the details. Again, there's a CPU, N95, motherboard, memory, there's that 16 gig module, Intel UHD graphics, there is the NVMe drive, 256 gigabyte M.2 in this case, and it says PCIe 1X, 8 gig transfer per second, and it's a Maxio Technology MAP 1202 NVMe. And then audio, it's got the integrated Alder Lake on the CPU. And here we've got the Realtek gigabit Ethernet and the 802.11ac wireless adapter, Intel 3165, and then the USB ports. Here's the Trigkey G4 with the Intel processor N100, Intel 7 process, 6-watt TDP, and you can see here you've got the 16 gigabyte of single channel DDR4 over here, and this is also based on the Alder Lake N process as the N95, and you can see here it's single channel at 3200 megahertz. 1600 times 2 would be 3200 megahertz effective clock. And here you've got Windows 11 Professional again, and just to confirm that everything registers. So you can see here Windows 11 Pro 22H2, and if we go down to activation, it shows it's been activated, so no problem there. And now if we go into the details a little bit here, go to the CPU, Intel processor N100, motherboard, memory, there's the memory, the single 16 gigabyte DDR4, RAM, UHD graphics, SATA TAPI drives, obviously nothing's installed on that, but there's a 512 gigabyte, again that's another Maxio technology MAP1202 NVMe. Audio, the integrated Alder Lake and the CPU, and network, you've got the Wi-Fi 6, AX101, and then the Realtek gigabit Ethernet, single gigabit Ethernet port, and then your USB ports. Here is the Trigkey G5, which has the N100 Intel processor N100, again with the Intel 7 process, TDP of 6 watts. And you can see here it's got the 16 gigs of DDR5 RAM. It says dual channel, which is confusing because there's just that single chip in there, and it is running at 4800 megahertz. And I'm not sure why it says dual channel, but it's neither here nor there. There's only a single chip in there, so it can only be running at single channel. And then the GPU, and then you can see here again Windows 11 Professional to confirm that it activates fine. Windows 11 Pro activation, and it is active. And to look at some more details here, the CPU, Intel processor N100, memory, there's that single chip of DDR5, UHD graphics, drives, SATA nothing, NVMe, again it's a Maxio technology, they all have this Maxio Technology MAP 1202 NVMe drive, and audio integrated network. Here we've got the Wi-Fi 6 AX101, and then the two Ethernet 2.5 gigabit link speed, which you can see right there, and then USB ports. Now I'm going to go ahead and do a quick file transfer here so you can see that it actually does transfer at 2.5 gigabit or 2500 megabit per second. Okay, now I have connected to another computer over a 2.5 gigabit connection. If you, this is the file I'm going to transfer. It's about 10 gigabytes in size. I'm going to go ahead and do copy. And I'm going to paste it just to the desktop. You can see here it's going at 230 megabytes per second. All right, we finally got to the benchmarks, and here's the things that we're going to take a look at. Basically, time to boot, USB, SATA, HDMI, DisplayPort performance, or more succinctly, the resolution and refresh rate of each of those ports. Doing some performance benchmarking with 7-zip, both zipping and unzipping, a large number of files, running Cinebench R23, encoding with Handbrake, and also looking at some of the storage metrics for the SSD, the M.2 SSD that came with the device, both with Crystal Disk Mark and a PowerShell script I wrote, doing 1 gigabyte and 1 megabyte file copies, and also over the wired 1 gigabit Ethernets on all devices, as well as the wired 2.5 gigabit Ethernet on the Trigkey G5 because that's the only device that came with 2.5 gigabit Ethernet ports. Then the wireless network performance, basically Wi-Fi 5 only, because even though the Trigkey G4 and G5 have Wi-Fi 6 or 802.11ax, I don't have any Wi-Fi 6 equipment currently to test that. And the thermal and power during idle and during benchmarking, looking at the CPU temps, clock, usage, TDP, then also the 2.5-inch SATA SSD idle temps. The reason for that is basically because you saw that the thermal pad on the M.2 drive would touch down to the bracket for the 2.5-inch SATA drive, and so I just wanted to see if there was any effect of actual on the SSD in that general area of the device while it's being pushed to its limits. And also the touch surface temps, total system power draw, and fan noise. I'm also going to look at some gaming performance as well as a Linux installation. So first up is the time to boot. And basically this is the time it took from pushing the power on button to the time that Windows booted up and I got the Windows boot up chime or sound effect. So you can see here clearly the U59 was much faster than the Trigkey G5, the S12 and the G4 were both pretty similar. Now looking at the display output, you saw that every device here has two HDMI ports and they all claim to support 4K 60 Hertz. And I did test that on a 4K 60 monitor that I have, and unfortunately for the Beelinks, it only came out at 4K 50 Hertz. It would only allow that maximum frequency or refresh, although I did get 4K 60 on these Trigkey G4 and G5. Now I did use the same monitor and the same cables for all of these, so I'm not sure what the problem was. I did actually swap out the cable as well, and it still resulted with the same 50 Hertz on the Beelink devices. However, 1080p 60 worked across the board on every device on each of the ports. Now the Beelink U59 and the Trigkey G5 did come with a video out on that. You can either use HDMI or DisplayPort if you have the appropriate cable. Now over HDMI, I only got a 4K 30 signal on both devices, but with USB-C to DisplayPort, I did get a 4K 60 Hertz signal, no problem. Now when it comes to multi-monitor support, because all the devices had at least the two HDMI ports, they all did support 1080p 60 in both instances, and also I was able to test the 4K plus 1080p because I only have a single 4K monitor, so I couldn't do a dual 4K test. But either way, 4K 50 on the Beelinks and 4K 60 on the G4 and G5 plus a 1080p 60 worked just fine. And in the case of the Beelink U59 and the Trigkey G5, those have that extra USB-C port which can act as a DisplayPort or HDMI port. And I was able to do triple monitor, no problem with that. I was able to do 4K 60 out of the USB-C on those, and then 1080p 60 out of both the HDMI all simultaneously. Now for some desktop performance, we've got 7-zip, and basically took a file which consists of 1065 files, or a folder consisting of 1065 files, total of 22.8 gigabytes, and timed the amount of time it took to zip and then unzip that package. So higher in this case is worse, lower is better because it's less time it took to compress and uncompress that file. And you can see here that the U59 with the Celeron N5105 was lagging behind a little bit from the other guys, but not by a significant amount. But definitely the newer chips did perform much better. Now when it comes to Cinebench, you can see here, in this case, higher is better because it's a higher performance score. The Beelink U59 tended to lag behind in both a single and multi-core performance metrics, although the N95 and the N100, both with DDR4 and DDR5, were pretty much neck and neck over here, with the G4 clearly ahead in the multi-core performance. Now onto Handbrake encoding. Basically took a 4K 60, 800 megabyte file and converted that to a 1080p 60 file. It's about a minute and a half long 4K video, and you can see here in this case, this is the time in seconds that it took to encode that file. 594 seconds, which is what, about almost 10 minutes here versus like 7 to 8 minutes for the newer chips. I also took a USB to NVMe adapter and plugged it into each of the USB ports on each of the devices just to verify performance. Did a quick crystal disk mark of the sequential read and write speeds. You can see here on each of these devices, you can see here 1,000 megabytes per second. Basically, this confirms that these are at least 10 gigabit ports. Now you can see here on the Beelink U59, the rear, bottom, rear, top, and the USB-C front, these are 5 gigabit ports. So although everything else is 10 gigabit. I also went through to verify the SATA port performance to make sure it was actually running at SATA 3 speeds at about 550 to 600 megabytes per second. You can see your sequential performance here in each of the devices was up to that performance metric. Now next I did a Windows file copy to the M.2 SSD that came with the system, and which in this case the Beelink U59 was M.2 500 gigabyte SATA, the Beelink was a M.2 256 gigabyte NVMe, and then the G4 and the G5 were 500 gigabyte NVMe drives. Now what you see here on the bottom is the total gigabytes transferred. I did 100 gigabytes total, and then the transfer speed on the vertical axis here in megabytes per second. So clearly the Beelink U59 with the SATA drive is not going to be able to exceed 600 megabytes per second anyways because of the SATA interface, but it did tend to average about 500 megabytes per second during the 1 gigabyte write, and then after about 70 something gigabytes tend to drop down to about 200 megabytes per second. Now compare that with the S12 and the Trigkey G4 and the Trigkey G5. Those all had the NVMe drives, although the S12 I believe did have the 256 gigabyte compared to the 512 gigabyte drives. And you can see here they all started at about 800 megabytes per second, although the Beelink S12 tended to drop down to about 200 to 300 megabytes per second after about 25 gigabytes written. And then the G4 and G5 tended to last about 60 gigabytes before dropping down to about 300 megabytes per second. And then we've got the read performance here, basically reading back those same 1 gigabyte files. The Beelink and the U59, the Trigkey G4, and the Trigkey G5 all tended to average, sorry this looks like a mess, but if you take the average here, and I'll show you the average chart in a second, or about 500 megabytes per second. For some reason the Beelink S12 dropped in performance during the reads, and not sure why that is. I did run it a second time and had similar performance, maybe a little bit higher than this, but not by a whole lot, and it averaged maybe about 200 megabytes per second after only about 20 gigabytes being read. So then I did the same thing with the 1 megabyte files, and the write performance here kind of looks like a mess, but I'll show the summary of this in a second. Then the 1 megabyte read performance here. You can see the Beelink U59 here kind of drops down midway through for some reason, but tends to jump back to about 250 megabytes per second. Now here's a summary of the averages of all those file transfers. You've got the 1 gigabyte write, 1 gigabyte read, 1 megabyte write, 1 megabyte read. And here's that Beelink S12. You can see here the write performance was about 290 megabytes per second. Then it dropped down to about average about 188 megabytes per second during the read. Not sure why that was, but when it came to the smaller file sizes, the 1 megabyte write seemed to perform about on par with these other guys over here, the other NVMe drives. And then I also did the same file transfer, but over the 1 gigabit Ethernet ports. And just keep in mind that the maximum speed you're going to see realistically over gigabit Ethernet port is about 112, 113 megabytes per second. So since these are all pretty much up there, there were really no performance bottlenecks that I could tell. This is a little slower here, but that's probably an anomaly. Then when it comes to 1 megabyte writes or the smaller file sizes, you can expect a significant drop in performance, which we see here. And the U59 tended to fare worse for some reason, but on the read side of things, it tended to do fine. So I don't really see any issues there. Now the Trigkey G5 actually happened to have a 2.5 gigabit Ethernet ports on it, so it's the only one I could test. But I did test it with the 1 gigabit Ethernet that you just saw, but also the 2.5 gigabit Ethernet. And here's the results. So we clearly can see it's the max realistic is about 283 megabytes per second, and it peaked out at that with the reads. Writes a little bit slower, and then also the 1 megabyte and write and read. You can see the performance is actually better than the 1 gigabyte, even though they were both within the almost within the 1 gigabit Ethernet performance speed. Now I also tested the Wi-Fi performance, only with 802.11ac, aka Wi-Fi 5, and both almost directly in range of the 6 foot of the access point, and also in another room about 50 feet away, going through a couple walls to show what it does with some interference. And I did the 1 gigabyte write, 1 gigabyte read, 1 megabyte write, and 1 megabyte read. All right, now we're going to take a look at the CPU usage temp and clocks through the Cinebench benchmark. And first of all, I'm going to kind of explain in this first slide, but then I'll plow through the other few devices here, starting with the Trigkey G5 with the N100 processor, N100 DDR5. What you have here on the vertical axis is both representing the CPU temperatures in degrees Celsius and the total CPU usage in percentage. So clearly that can't go above 100. But then on the right side here, we have the CPU clock in megahertz. And the temp is represented by the blue line, the usage is represented by this gray line, and the CPU clock is represented by the orange line. So you can see the N100, the temperatures started at around 80°C and kind of walked up slowly to about, I would say about 85°C near the end. And then you can see that the CPU usage was pretty much spiked at 100%. These little dips here are, as the test is going, as it fills out rendering that scene, as soon as it gets done, it kind of starts over again until the total time is up. So basically, those are the dips there. And then the actual CPU clock started at about 3,000 megahertz, and then it dropped down to about 2,800 megahertz throughout the rest of the test. Now compare that with the G4 with the N100 DDR4, and you can see here temperatures are much better, about 60 to 70 degrees Celsius, and then it was pegged at about 2,900 megahertz throughout the test, and also at 100% CPU usage. Now I will talk about the fan noise for a second, and I'll go into a little bit more detail later, but the G4 did tend to have much more audible fan noise throughout the test, and also in general, even at idle, tends to be a little bit louder than the other guys, but that may be a part of it. It may just have better cooling performance in general. Now the Beelink S12 with the N95 processor with DDR4 RAM, it started at about 80°C and went up to about 87, 88°C, and then it was pegged at about 2,700 megahertz on the CPU at 100% usage. And lastly, we've got the Beelink U59 with the Celeron N5105, the older generation CPU, and it hovered right around 80 to 81°C throughout the test at about 2,800 megahertz and 100% CPU usage. Now, if I took all those temps and then combined them together into one, you can see here we've got the yellow is the Beelink U59, gray is the Beelink S12, orange is the Trigkey G4, and blue is the Trigkey G5. The G4 tended to fare really well. It stayed under 70°C throughout, whereas these other guys crept up over the 80°C threshold and all the way up to about 90°C for the Beelink S12. Now, I also took the drive temperature of the M.2 drive as I did the SSD file copy test, and just to see if there was any really issues there, but I didn't notice any. It tended to, the Trigkey G5 was the worst here, but it still stayed under 50°C throughout the testing, and then the other guys tended to stay in the mid to low 40s or even below. Now we're going to take a look at the CPU TDP, or I guess the power draw of the CPU itself during idle and at load. And here at idle, you can see that the U59, this is the older CPU, the Celeron, tended to average at about 7.3 watts. You can see the averages right here, compared to the 1.2 to 2.0 watts of the N95 and N100 CPUs down here. So clearly it sips power there. But we'll compare that with the actual full system power draw as well. Now, if you take the CPU TDP at load, you can see here that the U59 was the lowest at about 14 watts on average. Yeah, you can see the averages right here. And the G5 pulled about over 20 watts on average up here. So there's a big 5 to 6 watt CPU power draw difference there. And then I also took the CPU temps throughout the run of Forza Horizon 4, and you can see the G4 ran at about 70 72C, 73C maybe, and the U59 was 78, 79C, and then the Trigkey G5 was about 85 to 90C, and then the Beelink S12 was up in the mid to upper 90s, actually near the end here. Now, during the benchmarking, I also took the temperatures of the M.2 as well as the SATA SSD just to get a feel for the temperatures inside the device itself and how it may affect the SSDs too. So you can see here, while during benchmarking, but the SSDs were idle, you can see here the temperatures of those respective devices, M.2 SSD and the Samsung 2.5-inch SATA drive. And you can see that on the S12, with the SATA drive doing nothing, it just had a temperature running of about 55C versus 52C on the U59. The Trigkey, we had the 45 and 49C respectively. So definitely about 50C on average inside the device itself. Then also during benchmarking, I did do a spot check of surface temperatures using a temperature gun, and it tended to be hottest just in specific spots. It wasn't like the whole surface was at this temperature, and but these were the hottest spots on the device on the top surface, and the U59 was 49C, S12 at 61C. Now that was, at that spot, I mean, if you push down on that spot for a little bit, it might get a little uncomfortable, but in general, the surface itself was not uncomfortable to touch. The G4 and G5 were 50 and 56 degrees C respectively. Then I did run some 3D Mark and Unigine benchmarks, both the Temps 3D Mark Time Spy, 3D Mark Firestrike, Unigine Heaven, and Unigine Superposition. And if you look here under Firestrike, under the physics result, you're going to have to multiply this by 10, just because I didn't want the scale to go all the way up to like 7,000, 8,000 and just dwarf all these other metrics right here. So you can see in general, though, despite the older CPU of the Celeron N5105, it actually is on par with these other guys for the most part on these synthetic benchmarks. Now I did run some game benchmarks on here at 720p low for the most part. And now this is not clearly a gaming machine, okay? But it is always interesting to see the performance of the integrated graphics on these latest processors and how they fare against, other systems. And also it's a good way to push the limits of the system to get temperature and CPU performance metrics. Now I do have a separate YouTube video which actually shows the game benchmarks for each of these PCs. So if you want to take a look at that, look down in the description. There should be a link down there. Now what you see here is the average FPS of each of these games on each of these devices. And then the darker area here represents the 1% low FPS. So for example, on this Dirt Rally here for this Beelink U59, see it has an average of 102.5, then a 1% low of about 79 frames per second. Speaking of which, now you can see here that the Celeron N5105 tended to fare comparably with all the other CPUs here in general, except for GTA 5 where it faltered significantly, but otherwise the rest of these really kind of were below any kind of playable frame rate anyway. So just but you can see performance wise it actually fared comparably. Now throughout all this I did do some power draw metrics as a power draw from the wall, and both from peak at boot, idle, light use, Cinebench, handbrake, and a handful of gaming benchmarks. And you can see here at boot it drew about 25 watts. While sitting idle, the Beelink drew about 13 watts, whereas the N95 and N100 CPUs drew about 10 watts on average. And then the with light use, basically viewing a YouTube video or something, this is the power draw from the wall. And Cinebench, and then handbrake, and then the rest of the games here. So you can see the games kind of pushed it the most, drawing about 30 to 35 watts from the wall. And if you noticed before, right, with the actual CPU TDP, or CPU power draw, with the U59 being much higher idle, it actually isn't that much higher as a system overall. When it comes to fan noise, it can be a bit objective depending on what your environment is in and how loud it actually is. So let me just say that the all devices were actually pretty quiet. Now the Trigkey G4 actually has a fan speed which seems higher than the others, so it is somewhat audible, although it's not, I didn't find it too annoying, just like a wisp, right? Now I am going to show you basically the decibel meter for at idle and then also at load and at boot up, so you can kind of get an idea for what it might be. And I'm also hopefully can get an idea for the sound coming from that device using my phone to record it. Now I did attempt to install Ubuntu 2204.2 LTS desktop on each of these mini PCs, and the installation process went well. There were no real issues during the installation, went pretty quick. And then when I actually got into the desktop, I went and tested for basic functionality. No real downtown benchmarking or anything, just basically to see if it would install and boot. And it did support the 4K monitors out of the box, no problem. And then I also checked for USB functionality, plugged in some USB drives, hard drive, thumb drive, and then also the SATA port. I was able to install the Samsung SSD in that SATA port and mount it just fine as well. And then checked for basic network functionality, browsing the web, and also just doing some basic file transfers over Ethernet and also over wireless, and no issues there except on the Trigkey devices that have the 802.11ax or the Wi-Fi 6 wireless adapters. It does not seem that there's any support in Ubuntu currently, at least in that version for that. Now, I did go online and do a rudimentary attempt to get it to work, and I was unable to, but I'm sure that that will be baked in eventually. No reason why they couldn't add Intel support, driver support for that. So overall, the experience was good, no real issues, and definitely an option. Now for my final thoughts. Really, there wasn't anything astonishingly different between the PCs other than that the N95 and the N100 PCs perform CPU-centric tasks about 15 to 20% faster than the Celeron N5105 on this Beelink U59. But for general web browsing and office tasks, it would be hard to notice any significant difference. From a functionality and I/O standpoint, though, the Trigkey G5 wins hands down. It's got the N100 CPU, DDR5. It's got the dual 2.5 gigabit Ethernet ports, which is really impressive. It's got the dual HDMI 4K60 ports, and then the 3 USB Type A at 10 gigabit and the USB Type C at 10 gigabit, plus it doubles as a display port at 4K60. Now, the fan noise was actually pretty good. However, it did tend to run a little bit toasty in some of these tests up in the mid-80s. However, it didn't seem to throttle at all. Now, the Trigkey G4 actually had the best cooling in general, but it definitely had a much more audible fan noise at idle as well as at load, so it's up to you whether that's tolerable or not. As far as the S12 is concerned, it was a good all-around performer, but it got pretty toasty during the benchmarking. It had about, CPU temps hit about 95C, peaked during one of the gaming benchmarks, otherwise about 90C or so in Cinebench. And it's got some decent functionality, very similar to this Trigkey G4. And then you've got the N5105 Beelink U59 here, which is a good performer overall. Surprisingly, in everything else, it seemed to match the performance in general. Now, the gaming performance was pretty much a wash, although most of the games tested were a bit unfair examples of what PCs could truly handle. In the games with reasonable frame rates like Batman Arkham Origins, Dirt Rally, and GTA 5, the N100 bested them all, actually the N100 and the Trigkey G5. So it seems that the single channel and the dual channel didn't have as much impact as one would expect, although maybe that had a reason why this Beelink U59 actually was able to keep up with these other devices in those gaming benchmarks. At this point, I don't think there's really any reason to consider a Celeron N5105 if you have the option, but if you happen upon a great deal, it's probably it's going to be fine and going to run along with the latest N95 N100 CPUs just fine. Considering one can easily find any of these mini PCs for under $200 usually, closer to $150 in many cases, you just can't go wrong. So I hope that was helpful and informative, and until next time, talk to you later.